Hello, my name is Isaac Castillo, president of the 2024-2025 Cal Poly Solar Boat Club, reporting from Effingham, Illinois, on our way to the Solar Splash competition. We are CPP Solar Boat Club, founded in 2001 as an offshoot of the Alternative Vehicle Club. This year will be our first time competing since 2017, and throughout the year we've been hard at work to be competitive. Nearly every part of our boat is brand new, and we are very excited to share it with you. Our team is split into two main teams, the electrical and mechanical. In the next few minutes, electrical team will tell you all about our brand new solar charging system and drive circuit. Our mechanical lead will tell you about our brand new boat hull, as well as our outboard and motor. Our featured mechanical lead will explain our motor mount and steering system. Major issues we've dealt with this year focus mostly on funding. We started the year with around $250 allotted, and so we need to do a bit of work. To alleviate our lack of funding, we did three different things: a GoFundMe account, submitted budget request to ASI, and Engineering Student Council hosted a carnival where we ran a solar-themed boat race, where attendees got to race a boat and win a little rubber ducky. We didn't make as much money as we wanted from this, but we got enough to keep working on our boat, and we're very thankful for everyone who participated. As I said earlier, we started GoFundMe and received over $2,000 from it, and because of this, we were able to finish our boat just in time, so a huge thank you to all our amazing donors. The last major thing we did was present in front of the ASI cabinet and receive the full amount we were allowed to receive of $6,000, and thank you to ASI because this is allowing us to get all the way to Solar Splash in Springfield, Ohio. Of course, not all of it was quite enough. We were able to get a lot more from both family and friends, such as a trailer to make sure that we could get the boat to Springfield. And a huge thank you to Alltrax for giving us a brand new SR48600 motor controller. We're extremely grateful to all our donors. We'd also like to thank our advisor, Professor Gerald Herder, and a huge thank you to our shop tech, Bill DeReuter, who without, we probably would not be able to finish that boat. A huge thank you to him. Thank you, and I hope you enjoy our video.
Hi, my name is Caden Neihart, and this year I served as the electrical team lead for Cal Poly Pomona's Solar Boat Club. I managed our electrical team projects, of which we had many this year, as this is the first time we've competed since 2018. We built a new drivetrain using our SR48600 motor controller from Alltrax. This motor controller is purposefully oversized for our use case, able to handle up to 600 amps, as to provide future proofing for future system upgrades as we hope to keep competing. We also retrofitted our old power cables with a larger 2-aught gauge to make it more durable and create less power losses. We made a dashboard for the boat to allow all boat controls to be easily accessible and visible to the skipper. We built a 36 volt battery pack using 6 of the 6 DZF22 batteries from UPS. These batteries are 12 volt, 22 amp hour, and overall we have 132 amp hours of battery power. So our new array, only 3 panels. Panel output is managed with an MPPT charge controller. All power utilized by our 2 DC motors, creating the rotation we need to get our boat moving in the water.
Hi, my name is Gerald Fernandez, and I was the mechanical lead for the solar boat team, and I just wanted to go over a couple things with you guys. Our design choices, our CFD analysis, as well as manufacturing composites. So for our design choice, we created multiple holes first and created a Excel sheet documenting all of the volume, the pounds, passive flotation, and through this we calculated the drag force using a wetted area of a triangle shape, just a simple one to narrow down our choices. And after those, we narrowed it down to 2 other choices, this one being our final choice, and then went into CFD analysis for both of those holes. So I'll just be showing you the final iteration, but through CFD we were able to put in the total wetted area as well as a definition, a goal definition for drag coefficient. That's what this is right here. Not sure if you can see that, but these are all constants, and this drag force is something that CFD solves for. For this one, we took the steady state of the drag force on the boat, which is around 200 pound force, plugged that in and got us our drag coefficient, which was about, I believe, 0.014. And then we moved on to the manufacturing process. So what we wanted to do originally was a composite infusion with carbon fiber. And just due to the complexity of the setup and how big the boat is, we weren't able to do vacuum infusion. So instead we opted for vacuum bag and layup. So I can show you some pictures over here. So here's us laying the carbon fiber and then vacuum bagging onto it. This gave us a rough shell of what we wanted. So we did a layer of carbon for the first one, 2 layers of Nomex, each 1/4 inch thick, and then a second layer on top of that, of the Nomex layer, creating a shell.
Hi, I'm Liam, and I worked on the mechanical side of the boat this year. To start, I'm going to talk about the steering. This year we wanted steering to be done by a regular wheel so that you don't have to use a tiller, and that sounds great, but is a little bit more complicated than that. To start, I decided to use a cable-driven system, so we're going to use paracord, which we can tighten. And so we're going to have that be connected to a rod off of the motor, which is going to pull it back and forth, to have paracord going off to the sides into some pulleys here that will have turnbuckles, and then go all the way up to the front of the boat where there's going to be more pulleys and turnbuckles, and then the wires will go in to a spool that it's going to be wrapped around a number of times to increase friction. And that spool is going to be on a aluminum piece of tubing that has been milled down, and on that steering column we're going to have 2 sets of two bearings, and those bearings are going to be connected to this inner skeleton frame that we're using. This frame creates rigidity, and we're able to strengthen it as necessary, and this way we also don't need to drill holes in our boat, which is very good. The steering column also has the steering wheel directly on it, so the direct movements from the steering wheel is going to be translated through that steering column to the spool that has the windings wrapped around it, and as you twist one way, that will unwrap it one way and then wrap it tighter the other way, pulling on the cable to move the motor back and forth. Now I'm going to talk about the motor mount. The motor mount, we had an original design from previous years, but that was a bit challenging to work with just because of all the iterations. So I started from the blackboard. I got just a plain drawing, brought that into SolidWorks, and traced out everything, dimensioned everything, and extruded that, and then I made a new loft up from the bottom surface to a top surface. The top surface was made on a plane at a specific distance so that we would have the proper length between the motor and the outboard system. And then we also decided to use some steel plates on the bottom because we realized that we needed to 3D print this because we're getting later into it. And that's been some issues, but we've really been working together as a team with myself and some other mechanical engineers to really figure out how we can add strength. And one of the ways we can do that is by having the steel plate on the bottom and running bolts all the way up through it, so the torque on the motor does not solely act on the 3D print, and instead acts on 4 other bolts going straight up and into the plate. So yeah, looking forward to seeing how things go. Thank you.